any set of strings over 0, 1, and the first part of the string should be exactly equal to the second part of the string. So it's of the form WW, where the first half is exactly equal to the second half. And then this W can contain anything over the symbol 0 and 1. And we have to show that this language is not context free. So first let
इस 5 रुपए के कीनू के लिए 1 लाख 70,000 का लैपटॉप गंदा कर दिया क्या यार चलो यार इस गरीब जैकेट
language
इस
is not
गरीब
context
अमीर लैपटॉप को साफ करते हैं यार इस गरीबी के चक्कर में मैंने बहुत कुछ गवाया यार गरीबी बर्बाद कर देती है यार गरीबी बहुत खराब चीज है यार बहुत खराब चीज है बहुत ही ज्यादा खराब चीज है गरीबी बहुत ही ज्यादा
free using the pumping lemma for
कश्मीर में गरीब नहीं रह सकता आपको जिंदा मार देंगे लोग people will bury you alive no matter where you are if you try and become poor you will have to pay dangerous blunt consequences like I did so I will never ever say कि गरीब रहो I will never say that. At the end of the day, nothing else can save you apart from your own education. तो 3:05 पे पढ़ाई हुई है स्टार्ट I'm rich, I can do these things. बहुत अमीर है मेरा Not you, और ब्रोकी चलो आगे चलते हैं
In the last last lecture, we have seen an example where using pumping lemma for context-free languages, we proved that a given language is not context-free. So in this lecture, we will be seeing another such example where using the pumping lemma for context-free languages, we will prove that a given language is not context-free. So let's see what is the language that we have here. We have a language given by L, which is given as WW, where W belongs to the set of symbols over 0 and 1. Now, what do we mean by this language? So this language says that it can contain any set of strings over 0, 1, and the first part of the string should be exactly equal to the second part of the string. So it's of the form WW, where the first half is exactly equal to the second half. And then this W can contain anything over the symbol 0 and 1. And we have to show that this language is not context free. So first, let us have a look at the rules once more that we need to follow in order to prove that a given language is not context free using the pumping lemma for context free languages. So these are the rules that we studied in the previous lectures, which are used to prove that a given language is not context free using the pumping lemma for context free languages. So first, we say that if A is a language and if it is context free, then it needs to have a pumping length P such that any string that belongs to the language where the length of the string is greater than or equal to the pumping length can be divided into 5 parts U, V, X, Y, and Z such that all these 3 conditions must be true. And in the last example, if you remember, we were focusing on condition number 1 and we did not really focus or we did not really check if condition number 2 and 3 were true or not. But in this example, what we will do is we will first make sure that conditions number 2 and 3 are true, and then we will check if condition number 1 is also true or not. And then we will see if all these 3 are true, then we can say that the language is context free. And if any of them is not true, it says that the language is not context free. So first, remember this conditions 3, which says that the length of V, X, and Y should be less than the pumping length. It should be less than or equal than the pumping length. And also the length of V and Y should be greater than 0. All right. And then when you raise V and Y to the powers of I, then the resultant string that we get must also lie in the language that we have. So let's see if these 3 conditions will be satisfied for our given language. All right, so we come back to our example, and what is the first step that we need to do? We need to first assume that L is a context-free language. So first we will assume that L is context-free, and then we will show that there is a contradiction to our assumption, and hence we'll prove that it is not context-free. So first of all, we will just assume that L is a context-free language. So if L is a context-free language, then L must have a pumping length. Let's call it P. Now we have to take a string S from our language L. Now how will we take this string? I already told you that this language L can contain strings of the symbols 0 and 1. So I take my string like this, 0 power P, 1 power P. So this is my first W. And then if my W is 0 power P, 1 power P, then my second W should be exactly the same. So since this is 0 power P, 1 power P, the second part also should be 0 power P, 1 power P. So we see that the first half is exactly equal to the second half, which is a property of our language L. So we have this string S, and now we have to divide our string S into parts U, V, X, Y, and Z. Now we have to divide this into these 5 parts, and let's see what are the possible ways in which we can divide our string S into parts U, V, X, Y, and Z. Alright, so first we will take our pumping length as 5. We assume that our pumping length P is equal to 5. So if P is equal to 5, then we have 0 power 5, 1 power 5, and so on. So if I expand and write it here, this is how my string looks like. 5 number of zeros followed by 5 number of ones followed by 5 number of zeros and 5 number of ones. Now let's look at case number 1. Case number 1 says that when you divide it into parts U, V, X, Y, and Z, the part V, X, Y does not straddle a boundary. Now what do you mean by straddle? Straddle means that it does not lie on either sides of a boundary, but it just lies in one part. Now let's see what are the boundaries that we have here. So here 0, this is one boundary, and the 1 ends here, this is another boundary, and this is another boundary. First boundary, second boundary, third boundary. Now the part VXY, it just lies in one part. It does not cross this boundary, nor does it cross this boundary. It just lies in one part. That is what I mean by VXY does not straddle a boundary. Now this is one way in which we can divide our string into these 5 parts. Now if we have divided into these 5 parts, and let's see if condition number 3 is holding, Vx and y. What is the length of Vx and y? It is 1, 2, 3. And is 3 less than our pumping length? Yes, our pumping length is 5 and it is less than 5. So condition number 3, it holds. And condition number 2 says that the length of V and y should be greater than 0. That is obvious from here. And condition number 1, that is what we have to check now. And condition number 1 says that if I raise u, v raised to I, x, y raised to I, z, then this resultant string that I obtain also must lie in the language L. Now instead of I, let me replace my I with 2. You can replace with other numbers also, but I will just take it as 2. So I'll take it as u, v raised to 2, x, y raised to 2, z. Now let us erase these parts v and y to the power of 2, and let's see what is the resultant string that we obtain. So first let's see, we have u, and what is our u? U is 0 0 0 0 0 1. Till here it is u. So let me write it down. 1 2 3 4 5, and this one over here. And then I have my v over here. What is v? This one here, it is v. And now v is raised to the power of 2. That means I have to write it 2 times. So this one I have to write it twice. 1 2. Then I have my x, and x has to be written as it is, and x is this one over here. So I have my 1. Then I have my y, which is raised to the power of 2. And this one over here is my y. And since it is raised to the power of 2, I have to write it twice. 1 1. Alright. And then we have our z. And what is z? From this one, the remaining things are all z. So let me write it down. 1. And then 5 zeros. 1 2 3 4 5. Followed by 5 ones. 1 2 3 4 5. Now this is the string that we get. Now let's see how many zeros and ones do we have here. 1 2 3 4 5. I have 5 number of zeros, and 1 2 3 4 5 6 7. I have 7 number of ones, followed by 5 number of zeros and 5 number of ones. 5 number of zeros and 5 number of ones. Now if you look here, I am having 5 number of zeros and 7 number of ones, but here I am having 5 number of zeros and 5 number of ones. So this part and this part, the first half is not equal to the second half. So this condition is not satisfied. So this resultant string that we obtained here does not belong to the language L. This does not belong to our language L. So the condition number 1 has failed for case number 1. Now let us look at case number 2. Let's see another way in which we can divide our string S into parts u, v, x, y, and z. Alright, so here we have the second case. I call it case number 2a because there is another case which is very much similar to this. So let me call it case number 2a, and it says that v, x, y straddles the first boundary. Now let's first just check what are our boundaries here. 0 ends here. This is my one boundary. This is another boundary, and this is another boundary. And if you look here, v, x, and y, this is our part v, x, and y, and we see that this is our boundary and it lies on either side of the boundary. This is my boundary and it lies on this side and also on this side. And this is my first boundary. So it is straddling the first boundary. So this is another way in which you can divide the string into parts u, v, x, y, and z. And here let's see what is the length of the part v, x, y. V, x, y, it is 1, 2, 3, 4, 5. And what was our pumping length? Our pumping length was also 5. So condition number 3 says that the length of vxy must be less than or equal to the pumping length. So it is equal to the pumping length. So condition number 3 is true. And what is condition number 2? It says that the length of v and y must be greater than 0. That is obvious from here. Now let's come to condition number 1, which says that if you raise it to the power I like this, then the resultant string must also lie in the language. Now as usual, as we were doing before, I will raise it to the power of 2.
मैं नहीं कर सकता माफ किसी
Let's see this string. What will it give? Here I have my u. What is my u? U contains 3 zeros. 1, 2, 3. And then I have my v. Here my v is 0, 0. And it is raised to the power of 2, so I have to write it twice. So 0, 0, if I write it twice, I have to write 0, 0, 0, 0. And then I have my x, which is this one over here. And x is just x, so it is just 1. And then I have y, which is 1, 1.
Still.
And y is again raised to the power of 2, so I have to write y 2 times, which is 1, 1, 1, 1. And then I have my z. And what is z? 1, 1. And all these remaining things are my z. So let me write it down. 1, 1, followed by 5 zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 ones. Now let's see how many ones and zeros do we have here. 1, 2, 3, 4, 5, 6, 7. 7 number of zeros. And 1, 2, 3, 4, 5, 6, 7. 7 number of ones. And then how many zeros and ones do we have here? 5, 5. And 5 number of ones. Now if you look here we have 7 number of zeros and 7 number of ones. This is my first part, but in the second part I don't have 7 number of zeros and ones, but I only have 5 number of zeros and ones. So the first half is not equal to the second half. This is also not a property of our language, and hence this string that we obtain here also does not belong to our language L. So condition number 1 has failed again, even for case number 2a. Now let us look at the next case. So here we have our next case, which I call it case 2b, and I call it 2b because this is very much similar to our previous case that we have discussed. And it says that the part Vxy straddles the third boundary. Now let's just see here what are our boundaries. Here 0 ends here, this is one boundary, 1 ends here, this is another boundary, this 0 ends here, this is another boundary. So this is my first, second, third, this is the third boundary, and we see that the part Vxy straddles the third boundary. That means it lies on either sides of the third boundary. So if we have it divided in this way, let us see if it satisfies our conditions 1, 2 and 3. So looking at condition 3, we see that Vxy, the length is 1, 2, 3, 4, 5. 5 is the length of Vxy, and the length of our pumping length is also 5. So condition 3 is satisfied, and condition number 2, which says that the length of V and Y should be greater than 0, also is satisfied. Now let us see condition number 1, where I will take U, V square, X, Y square, Z, and let's see the resultant string that we obtain from here lies in our language or not. So what is my U? This whole thing is my U. 5 number of zeros, 1, 2, 3, 4, 5. 5 number of ones, 1, 2, 3, 4, 5. And 3 number of zeros, 1, 2, 3. This is my U. And V square, what is my V? I take my V as the 2 zeros over here. And since it is raised to 2, I have to write it twice. 0, 0, 0, 0. And then I have X over here, which is just this one. And this X, I'll write it as 1. And then I have Y, which is 1, 1. And Y has to be raised to the power of 2. So I have to write this 2 times, 1, 1, 1, 1. Then I have Z, and Z is 2 ones over here. Now let's count how many zeros and ones we have. We have here 5 number of zeros, followed by 5 number of ones, and we have 1, 2, 3, 4, 5, 6, 7 number of zeros over here, and here 1, 2, 3, 4, 5, 6, 7. 7 number of ones. So here again we see that the first part is not equal to the second part. The first half and second half are not the same. So this also does not belong to our language L. So again, condition number 1 does not hold. So even in this case, we found out condition number 1 is not true. Now let's go to the next case, which will be our final case. Now here we come to case 3, which is our last case, and it says that Vxy, the part Vxy, straddles the midpoint. Now let's just mark our boundaries again. This is my boundary, this is my boundary, this is my boundary, and this is the midpoint, right? The middle boundary, this is the midpoint of our string, and it says that the part Vxy straddles the midpoint. So this is our midpoint, and we see that Vxy, it lies on either side of the midpoint. It lies this side and also it lies this side. So if we divide it in this way, let's see if our conditions 1, 2 and 3 are satisfied or not. So you can just check it. V, X and Y, the length is 5 and our pumping length is also 5. Condition 3 is satisfied. Condition 2 is also satisfied. You can see it is obvious from here. And let us check the condition number 1 by raising it to the power of 2, U, V square, X, Y square and Z. Now what is my U? U is this one, 1, 2, 3, 4, 5 and these 2 ones. And then V, what is my V? I will take these 2 ones as my V. So I have to raise it to the power of 2, so I have to write it twice, 1, 2, 3, 4. And X is this one, so X has to be written as it is. So X is 1 and this is 1 here, and Y is 0, 0. And Y has to be raised to the power of 2, so it is 0, 0, 0, 0. I have to write it twice. And then Z, and what is Z? From this 0 till the end it is Z. So 3 zeros, 1, 2, 3, followed by 5 ones. 1, 2, 3, 4, 5. Now let's count how many zeros and ones we have. We have here 1, 2, 3, 4, 5 number of zeros, followed by 1, 2, 3, 4, 5, 6, 7. 7 number of ones. And here we have 1, 2, 3, 4, 5, 6, 7. 7 number of zeros and 5 number of ones. So here again we see that the first part is not equal to the second part. So this also does not belong to the language L. So we see that we have divided our string S into parts U, V, X, Y, and Z using 4 different cases actually. And we see that in all the 4 cases, in whichever way you divide it, all the 3 conditions that we have studied for pumping lemma cannot be satisfied. Condition number 2 and 3 were satisfied, but condition number 1 was not satisfied. So only if all the conditions are simultaneously satisfied, we can say that it is a context-free language. But since condition number 1 could not be satisfied, it shows that our assumption which said that L is a context-free language is not true. It is a contradiction to our assumption, and hence we say that our language L is not context-free. So that is how, using pumping lemma for context-free languages, we prove that a given language is not context-free. So this was another example. I hope it was clear to you. Thank you for watching and see you in the next one.
मुझे कुछ समझ में नहीं आया.
This was another example. I hope it was clear to you.
मैं give up कभी नहीं.
Language says that it can contain any set of strings over 0, 1.
Example से पहले rules पढ़ते हैं. पढ़ने का शौक नहीं है, लेकिन जब सब हर कोई चाह रहा है आप हार जाओ, फिर तो भाई पढ़ना ही पड़ेगा. फिर तो अलग ही, फिर तो एडिक्शन हो जाती है पढ़ाई की.
अंकल एक
और सबक सिखाना पढ़ाई से अच्छा, और एजुकेटेड वे में भाई बदला लेना, भाई मतलब लोग दंग रह जाएं हुआ क्या, उनको सदमा पहुंच जाए आपने क्या किया, कुछ नहीं, बस आप पढ़ते रहे, भाई वो मजा आएगा।
Pumping lemma for context-free languages. So what is a pumping lemma for context-free languages? Pumping lemma for context-free language is used to prove that a language is not context-free. So if you remember, we have already studied about pumping lemma for regular languages, where we use the pumping lemma to prove that a given language is not regular. So if you have not watched that video and if you need to
चुप, शांति। कि ये स्पिरिचुअली थोड़ी सी ग्रो हो गई है, मतलब मुझे लगता है स्पिरिचुअली ग्रो करती है, बट अनफॉर्चुनेटली दुनिया ऐसी है नहीं। मैं इसको क्या समझाऊं, इसका क्या हाल होगा। तो क्या इन अ फॉर्मल theory of context-free language is a language generated by some context-free grammar. The set of all context-free languages is identical to the set of languages accepted by push-down automata. Context-free grammar is defined by four tuples as G is equal to V, sigma, S and P, where V is a set of variables or non-terminal symbols. Sigma is a set of terminal symbols, S is the start symbol, P is the production rule. P is the production rule. Context-free language अकेले रहो और पैसों के पीछे रहो, जहाँ पैसा जाए वहां जाओ। सड़क पे चल रहे हो तो गरीब दिखे इग्नोर मारो, हर एक गरीब को इग्नोर करना ये भी सक्सेस की निशानी है, क्योंकि भाई वो सब इतना ज्यादा मतलबी हो गए हैं ना यार। अगर आप में सिंपैथी है तो वो आपका, आपकी जेब में क्या है उसी से मतलब रखते हैं, आपका हालात कैसे हैं वो नहीं रखते। तो इसलिए उनकी साइड कभी भी नहीं लेनी, कुछ भी हो जाए। So S क्या है?
To study about that, you can watch it in this playlist. And if you have already watched it and if you have already studied it, then this pumping lemma for context-free languages should not be a difficult topic for you, because the pumping lemma for context-free languages is almost similar with that of the pumping lemma for regular languages. But yes, there are a few differences. So we shall see what they are, and we shall see how we can use this pumping lemma to prove that a language is not context-free. Alright, so let's see how we can do it. If A is a context-free language, then A has a pumping length P such that any string S where the length of S is greater than or equal to P may be divided into 5 pieces S equal to U, V, X, Y, and Z, such that the following conditions must be true. So what we do is, let's say that we have a language called A. So we say that if A is a context-free language, then A will have a pumping length P. So we don't know what is the pumping length P, but it will have some pumping length such that any string S. So S is a string from this language.
8 मिनट की पढ़ाई बस पहले मैं फ्लॉसिंग करके आया। हाँ। कितना टाइम आया? 3:38 पे उठूंगा मैं। चलो आगे चलते हैं।
A where the length of S is greater than or equal to the pumping length P, that string S can be divided into 5 pieces such that S equal to U, V, X, Y, and Z. So if you remember, when we studied for pumping lemma for regular languages, we divided the string into 3 pieces. But in this pumping lemma for context-free language, we will divide the string into 5 pieces, U, V, X, Y, and Z, such that the following conditions must be true. So if you divide it into 5 pieces like this, these 3 conditions must be true. And what are they? U, V raised to I, X, Y raised to I, Z is in A for every I greater than or equal to 0. So you have divided S into U, V, X, Y, and Z, and here if you raise V to the power of I and Y to the power of I, where I is greater than or equal to 0, then the string that you get even after doing this should also be in A. That means that string also should belong to the language A. And the second condition says that the length of V and Y should be greater than 0. And then the third condition says that the length of V, X, and Y should be less than or equal to P, which is our pumping length. So remember that these U, V, X, Y, Z, they are not strings, but they are the parts into which you have divided the string S. And after you divide this, these three conditions must be true. And if these three conditions are true, then we can say that it is a context-free language. So we are going to prove that a language is not context-free using this pumping lemma. So this is the conditions that we know, and let's see how we can prove it using pumping lemma. So in order to prove that a language is not context-free using pumping lemma for context-free languages, we have to follow the steps that are given below. So just as we did in the case of pumping lemma for regular languages, even in this case, we will prove it using contradiction. Alright, so here we have the three conditions given and we already defined them. And now, since we are going to prove it using contradiction, what we will do is we will assume that A is context-free. So we have a language that we call A, and we will assume that it is context-free for the beginning. So we have already read that if a language is context-free, then it has to have a pumping length, and let's call it P. So as we assumed A is context-free, so it should have a pumping length, which we will call P. And then all the strings longer than P can be pumped. So any string whose length is greater than or equal to P can be pumped. That's what we read above. Now what we will do is we will find a string S in A such that the length of S is greater than or equal to P. So we have our language A, and from this language A, we will take a string which we will call S such that the length of this string S should be greater than or equal to P, which is our pumping length. Now after you take that string S, we will divide that S into 5 parts: U, V, X, Y, and Z. So we have a string and it is divided into 5 parts now. Now we will show that U, V raised to I, X, Y raised to I, Z does not belong to A for some value of I. So you have divided this S into these many parts. So when it is divided in this way, it is lying in this language A. We know that. Now we will show that this string S, which you have divided into these 5 parts, this part of V and this part of Y, when you raise it to some power of I, that means if you repeat this V part and Y part some I number of times, this new string that you obtain, you have to show that it does not belong to the language A. So we don't know what is the language right now, but when you have the example, you will know some rules that have to be followed for the language. So once you divide it in this way and raise it to these powers, you have to show that it does not belong to this language A. After that, consider the ways that S can be divided into U, V, X, Y, and Z. So this string S, when you divide it into U, V, X, Y, and Z, there are many ways in which you can divide it into these 5 parts. So consider all the ways in which you can divide the string S into these 5 parts, and after you find them out, show that none of these can satisfy all the 3 pumping conditions at the same time. So what are the 3 pumping conditions? These 3 conditions that we have read over here. So once you find all the ways in which S can be divided into these 5 parts, show that those divided parts cannot satisfy these 3 conditions of pumping lemma at the same time. So since it cannot satisfy all the 3 pumping conditions at the same time, S cannot be pumped, which is a contradiction to our assumption that A is a context-free language. If A is a context-free language, then it should be able to be pumped. But since we find that it cannot be pumped, we get a contradiction. Thus, we prove that A is not a context-free language. So these are the steps that you have to follow in order to prove that a given language is not context-free using the pumping lemma for context-free languages. So don't worry even if you feel a little bit confused seeing all these rules and steps. In the next lecture, we will be taking an example in which we will clearly see how to perform these steps in order to prove that a given language is not context-free using the pumping lemma for context-free languages. So thank you for watching this, and see you in the next lecture with an example which will clarify this further.
Study materials leaving you stuck and confused? Chegg has what you need with expert help made for your courses. Find help for...
In the last lecture, we have studied about pumping lemma for context-free languages, and in this lecture, we will be taking an example to see and figure out how the pumping lemma for context-free languages actually works. So here we have an example language given, L equal to A power n, B power n, C power n, where n is greater than or equal to 0. So the meaning of this language is that we can have symbols of the form A, B, C, and then the number of A's should be equal to the number of B's, and it also should be equal to the number of C's. That means if you have n number of A's, you should also have n number of B's and also n number of C's. So it means the number of A, B, and C should always be the same. That is the rule of this language that we have. So our task is to show that this language is not context-free, and we will do this using pumping lemma for context-free languages. So let's see what are the steps that we need to follow. So the first step is we will assume that the language L is context-free. And why are we doing this? We studied in the previous lecture that the way we are going to prove this is using contradiction. So first we will assume that L is context-free, and we will show that there is a contradiction to our assumption, and hence it is not context-free. So we'll see how we do that. So first we have this language L and we assume that it is context-free. So if it is context-free, then the language L must have a pumping length. This also we studied, and we will call the pumping length P. And now we will take a string S such that S is equal to A power P, B power P, and C power P, where P is our pumping length. And then we have to divide S into 5 parts: U, V, X, Y, and Z. So let us just look at the rules of this pumping lemma that we studied in the previous lecture, just to recall those. So this is the rule of pumping lemma that we studied in the previous lecture. And we said that if a language is context-free, then it will have a pumping length. So we already assumed that our language is context-free, so it will have a pumping length P. And then we have to divide our language into 5 pieces: U, V, X, Y, and Z, which we will do. And after dividing that, you have to show that U, V raised to I, X, Y raised to I, Z also belongs to the same language for every I greater than 0. So this condition must hold if the language is context-free. And also condition 2 and 3 must hold. So we will focus on condition number 1.
3:38 हो गया, 5 मिनट का ब्रेक। अभी 1 घंटा और पढ़ना है, 3
So let's
घंटे
go
को अभी 1
back to our problem.
पढ़ना है हर दिन, नो मैटर व्हाट, एटलीस्ट। चलो